So here we have that a cycle race across America is 3,069.25 miles in length, and Juan knows his average speed for this previous races is 15.12 miles per hour. And we're told that for the next race across America, he will cycle for 8 hours per day. And we're then asked to estimate, being the key word here, how many days Juan will take to complete the race. So a really key point here is that we're working with an estimation of the number of days. So we're not going to be actually calculating the exact number of days. We're going to be using rounded values and values that are going to be easier to work with to work out these number of days. So to start here, I'm going to start by rounding these values to some sensible kind of numbers that are going to be a lot easier to work with and provide a good estimate for me. So, if I take the 3,069.25 miles, a sensible estimate for this would be something probably to one or two significant figures, but because this number is so close to 3,000, I'm just going to round it down to 3,000 miles. It's a really nice whole number and it's going to be really easy to work with later on in the question. We also then have 15.12 miles per hour. And similarly here, this is very close to a whole number, very close to 15. And if I look at 3,000 miles and 15 miles an hour, these are really nice numbers that are going to work well and work together in these calculations. So I'm going to round this one to 15 miles per hour. I know the average speed and I know the distance, and I'm looking for time so that I can work out how many days it's going to take. So if I get my speed, distance, time triangle to work out how to calculate time, so we have distance and then we have speed and time at the bottom of the triangle, like so. And if I want to calculate time, in this instance, I simply do distance and then divide that by the average speed in this case. So the distance that I've rounded this distance to a distance of 3,000 miles, and then I'm dividing that by the speed, the average speed, which I've rounded to 15. And these numbers are going to work really nicely together, so we know we've chosen good estimates for these. So then I can take this and calculate this, and it comes out as an answer of 200. And the units here, if we have miles here and then miles per hour, the miles cancel out and we're basically left with 200 hours. We then need to work out how many days this is going to take Juan, and if he is doing 8 hours of cycling per day, then we can simply take this 200 and divide it by 8 to work out how many days it's going to take with 8 hours of cycling each day. So 200 divided by 8 is going to give us an answer of 25. So 25 days is what it's the estimated value that it will take to complete this race. And that's a good estimate. We could have used different numbers throughout the question. You could change them slightly and still get to a reasonably similar answer, but we need to make sure that we do estimate this and don't calculate it accurately, because we would not obtain the marks here for that. So the marks are distributed firstly for basically doing the time calculation, so the 3,000 divided by the 15, or some similar values, so some kind of distance over speed. And then the second mark is for dividing this down by 8 to work out how many days it should take if we're doing 8 hours of cycling a day. And then the final mark is for a correct final answer, which it could be a range of different things depending on which input values you've used. I'm now told that Juan trains for the race. The average speed he can cycle at increases, and it's now 16.27 miles per hour. And we're asked, how does this affect your answer to part A of the question? So in order to work this out, I'm going to go back and have a look at the equation that we used. So I used the fact that time is equal to distance over speed. Now we're told here that the average speed, so the speed that S in this equation, is going to increase after his training. And an increase in speed in this instance is going to cause a decrease in time, because time and speed are inversely proportional. So time's proportional to 1 over speed. So as speed increases, time's going to do the opposite and decrease. So if less time is taken to complete this race, and in the previous part of the question we were working out the number of days it would take, doing 8 hours each day, if less time's taken when dividing this by 8, we're going to require less days to complete the race. So to get the mark here, you simply need to write the fact that less days are required. There's no explanation needed here, but it's always good to understand the reasoning behind the answer and see how this works, linking back to the equation. Alternatively here, we could have gone down the estimate route and said that 16.27 could still be rounded down to 15, like we did in the previous part of the question, and because we're working with estimates, this wouldn't actually affect our answer. That would also gain us the mark here. So either way, going about this question would gain us this single mark and bring us to the end of this question.